says if you have peak loads in certain areas, how to get it from one place to the other. This represents a huge opportunity for the country, and the DOE grants that came out yesterday, you know, a small amount of money, a few $1 billion to about 200 projects, they're expecting to save about 4% of the national energy consumption as a result of implementing some consumer knowledge and some network management techniques. That equates to about $21 billion a year in savings. Elements of the grid, basically in the center is kind of the operations, kind of a network operations center that needs to come together. There's the generation, transmission, and distribution, which people tend to think of as power utility. There's the input into those systems, meaning the raw materials and the maintenance of those systems. And then there are these consumers, industrial, commercial, and residential. Now there are a number of new opportunities, distributed generation and storage, and this notion of smart homes. And smart homes is an interesting idea in terms of homes being able to provide power back to the network. And also the thought that's occurring in the automotive industry is that certain forms of cars now may be able to port energy from location to location and serve as a portion of transportation. So when you think about this, the work that we've been doing for the Department of Energy at Oak Ridge is to put together a network operations center for all of the networks. So XL, PG&E, we're laying over the top of all of those to figure out what the national network for energy looks like. And here in the Colorado area, you can identify a handful of rural and local energy providers that are beginning to net together as well. Technologies, necessary technologies and keys, and the panel members here will emphasize their views on a couple of important ones. Power distribution and transmission wide area measurement systems to basically know where and when power is loaded on the system, advanced protections and controls, and high efficiency transmissions. Carbon nanotube transmission lines are going to come into favor. In terms of operations, you know, if you think about a secure network operations center in the form of telecommunications available all the time, extremely efficient, and you think about the application of technology that has occurred in business process or in any facet of the economy, that application needs to occur here in the energy markets. And virtualization and decision management and interoperability and closing the loop with how consumers are behaving on the smart grid is going to be critically important. So the first thing that was done with the DOE was yesterday was a large-scale set of grants to put smart metering out, millions of smart meters. And the first cycle that's going to come back in is a lot of consumer knowledge, which is going to go into this operations cycle here, which says, from a systems engineering sense, make sure you understand what problem you're solving based on the consumer behaviors. So this is going to be a cycle that repeats itself a couple of times. Integrated communications network, bringing, you know, the 22nd generation network and Wi-Fi, and I know a number of the panelists are going to talk about that. Distribution and generation, we basically have to find techniques to produce power that are cost efficient and don't require sustained subsidies. And so what we're going to have to do is examine you know, investment tax credits or production tax credits that are sustaining wind and solar, but we're also going to have to take a look at the cost of technologies to help us there and make it cheaper to produce those energy and get them there. In the western region, a lot of wind power generation was put in place, but no one wired any transmission or distribution into those wind farms. And so now in the Midwest, there's quite a few farms that are sitting idle because the produced power can't get to market. And lastly, in terms of consumers, industrial, commercial, and residential, there are a number of things going into offices, homes, and businesses, large government operations. And one of the most interesting things is demand response. And that is use of the network operations and the smart metering. And we're taking a look at when to bring power to the response. And we've had some interesting conversations up on the diagonal where we've examined peak pricing for power versus storage options. And we've done some studies with some firms about storing power overnight and doing some demand response and certain kinds of operations and off-peak. So there is a real economic cost benefit work done there. In 2008, the Department of Energy did a study in terms of the metrics associated with the smart grid. This is actually a very good study. It's published this summer. It talks about the maturity of the things necessary to move forward, and I'm just going to talk about the two downward trends, the red arrows, and basically the study finds fault that everybody has recognized these as frailties or issues for a number of years, and yet nothing seems to be happening with respect to it. Now, each of these are common themes about what needs to occur, and if you take a look at the DOE, RBE grants, or the work that's being done in universities or in small companies, against each one of these items, there are a number of firms, a number of companies taking a full frontal assault on those technologies. The last piece of this is venture capital. It's going to take quite a bit of money to recapitalize that grid in pieces. In a second, I'm going to talk about that. So, just very quickly, where we are and where we're going in terms of advanced metering. Again, the DOE grant puts, 18 million smart meters out. This was an announcement yesterday, so the funding puts that out. And by my count, there's about 160,000 smart meters going in the Rocky Mountain region. Pueblo got a big chunk, Fort Collins got a big chunk, and Wyoming, Cheyenne, Wyoming got a big chunk of them. That's in addition to the work that's already going on at Boulder. Demand response, the minute the smart meters go in, the software goes in, that goes to the power generation distribution, you get a demand response, and that will likely begin locally. Grid optimization, we see a number of large-scale producers starting to look at that as they're making their capital investment decisions about replacing capacities. Superconducting cables, I mentioned those, and the one down here I'll talk a little bit more about is microgrids. We see a number of corporations on campuses looking at microgrids. One of the opportunities that we've been following is over at Fitzsimmons at the hospital over there. They're going to put in an opportunity to produce and generate power there. Obstacles moving forward, from a technology and engineering sense, what is the appropriate architecture? Certainly not the Polaroid picture of what we got, and so